Okay, so type of defects. What kind of the defects are there? The types of defects, if we talk about, the first one is the point defects. Point defects means zero dimension. Zero dimension means the localized disruption involving one or the few atoms or ions. What I mean, the single atoms has been deviated. See the example. I mean, if we talk about the line point defects, there are the three kind of the things. First one is the valency. This one is the interstitial atoms and substitutional atoms. What does it mean? First one, I mean, with the first vacancy means the atom which was present at the particular position, at their own position, they have been left out from their own place, right? Got it? So there is a vacancy. There is a kind of, in this case, if we take an example of this one, what what would you suggest? The packing efficiency will increase or decrease? Tell me.
Decrease, sir.
Exactly. Because the atom, they were present at their place, they have been removed. I mean, whatever the reason behind that, that we are not going in that depth. But if atoms has been removed from their particular position, it means they are compromising the properties. And if you just take another one example of the packing efficiency, it means they are, they would not be the same of the 74%, whatever the percentage was there, they will decrease. Okay, so this is the vacancy. If we talk about the interstitial atoms, it means all are perfectly arranged. Okay, but some other foreign elements have been, has come here. Okay, so I mean, they all were arranged in a good, in a fashion way, but other foreign elements have been come and sit here. You can say they have, uh, you know, they have occupied this free space. Okay, so now in this case, obviously the packing, if we talk about the packing efficiency, that it will increase because the volume occupied the element overall, that will be increased, and it means the packing efficiency will increase in that kind of things. So this is example where everything is perfect, but some other foreign elements come at that particular place, at a free space. Okay, now we talk about the substitution means everything is perfect, but the atom which was present here, that has been replaced by the other element, other ion, other atoms, that will also change because suppose these all are of same nature. Okay, these all are of the same nature, but the one of the element which has been of the same group, which was the same group, has been removed, and some other elements has come at that particular place. It means that would not contribute the same efficiency, same packing efficiency. Obviously, it depends what the kind of the metal, what the kind of the element that has atom that has been come here. Because if this has the same, I mean, less capacity of occupying the volume, then it will compromise and it will decrease the overall packing efficiency. But if the foreign element that has been come here instead of replacing the parent element, parent atoms, then if they are occupying the more volume, then it will increase the packing efficiency, right? So there are the three kinds of, basically first we are discussing the point defects. Yeah, point defects. So in point defect means zero dimension, that means the dimension is the same, okay, as it was earlier. Okay, so in point defects there are three kind of defects. First one is the vacancy, the second one is the interstitial atoms, and third one is the substitutional atoms. Okay, as here is a description, as missing the atoms in the lattice, the vacancy. As you can see, vacancy in the metal increases the diffusion rates. Okay, diffusion rates will increase. Why? Because there is a space in which the molecules can diffuse very easily. If we talk about the interstitial, the extra atoms occupy the position between the regular lattice point. I mean, whatever their main position, they are perfectly arranged, but some foreign elements comes out and sit in the space which is not occupied by their molecules or atoms. Okay, in substitutional, the same. The foreign element, in the substitutional, the main atom has been removed or replaced by this foreign element. Okay, so in interstitial, they are not disturbing the element, parent element or atoms. They are at their own place. But in substitutional, they are basically removing or they are replacing the place. Okay, so some foreign element coming out and they are removing the elements. Okay, or atoms. Okay, so these are the examples. Now, where there are the two kinds of defects more: Frenkel defects and Schottky defect. What are the difference between? You can see, yeah, here. Suppose a cation means the positive charge is displaced from its lattice side to an interstitial position. Okay, so suppose it was the place of cation. Okay, but it has been removed and come out from here. It means they have you know changed the places, like the interstitial. Interstitial means they are not disturbing the other elements, but in between the space that is not occupied by the other, they are coming out. So they have just coming out from here. Not no foreign element is coming from other side. In itself, cation means a positive charge. Suppose this is a positive charge, and they here it has come out to here. So I mean it. If we talk about this particular cell, so it is not disturbing. Okay, here, all are present at their same fashion, but this is coming out from nearby and sitting here. So living here is a vacancy at the same time. What is the difference between the uh, you know interstitial vacancy or the Frenkel, in which you can say the same arrangement, not a foreign element. At the same time, they are basically making the two kind of the defects. First one is the vacancy defect, and here is the interstitial defect, because this cation is coming from here to here, right? So it means they are living two kind of defect together. So this is known as the Frankel defects. And if we talk about the Schottky defect, okay, so here you can see the equal number of cations and anions are missing, maintaining the electrical neutrality. Okay, so here this one is cation, the positive charge. This is the positive charge, and this one is the negative charge. Both are missing together. Both are missing together means they are the kind of the vacancy, right? Because missing out means vacancy, and if vacancy is present, but the overall the electrical neutrality, the charge balanced is same, because if some positive equal amount of the positive and equal amount of the negative charge has been removed or added to the things, then it would be not change your it would not change your electrical neutrality, right? Because whatever the neutrality means, if only positive charge will come out, then it will increase the positivity. If negative charge will come, then it will increase the negativity. But in case of you know the Schottky defect, then we are having this both together. They are missing together. Positive and negative both are missing together. It means they are of kind of the vacancy. Here is a basically vacant area, but neutrality will be not compromised. This is a Schottky defect. Okay.